for letting me put you on the spot. Dan, thanks for starting the recording there. What I'd like to do is take all of the different roles and responsibilities and things that you all just described as your responsibilities at Ferris, and see if I can tailor the capabilities and really the mission of the Makerspace to how it might support what you do. And that might sound like a really tall order, but it's not, because a Makerspace is just a place where things can happen, because it contains some technology, but it's not really the technology that makes stuff happen. It's actually the students that tend to congregate around this place. What I'm about to show you is going to be a really messy place by comparison to some of the classrooms or maybe more established labs on campus. And the reason it's going to seem kind of messy is twofold. One, until this semester, the Makerspace had zero budget. It's gotten no funding. It's been supported entirely out of the S&E budgets of programs that felt like this was important to give our students the capabilities that are here. Like I said, that's changed a little bit. We got a little bit of money from the new Dean of the College of Engineering Technology. Big shout out to Michael Staley for that. And so that's part of the reason why it looks the way it does. The second reason, and probably more importantly, is I don't own this. Nobody owns this lab. I teach in product design. This is not product design space. In fact, product design students don't even make up the largest percentage of students who use the Makerspace. It's actually other programs. So it's not even owned by the college. It's owned by the university student population. This is their spot. And we all know what their dorm rooms look like. So it kind of reflects a little bit here. Yeah, I was a college student too. I'm not digging on anybody there. It's a little bit of a mess because they own it. So they maintain it. They break stuff all the time, but then they also fix it. And that breaking, fixing process is learning, is it not? Like everything that we do that's teaching is a process of breaking, studying that, and then doing it better the next time. So that's the Makerspace is just a place where that happens. But the types of things we're breaking are like 3D printers and pieces of cardboard and stuff like that that can be easily repaired. So it kind of makes some sense. So that's all the Makerspace is. It's an open lab owned by nobody. Students run it like, so I'm the Makerspace director, but I have a staff of students and they're here all the time. I barely come down here because honestly, if I walk through the door, 2 hours evaporate from my life. And I don't know how that happens, but it's like this black hole of time. So I don't come down here. The only thing I do is troubleshoot things occasionally and buy them stuff when they say that something needs to be repaired. That's it. That's my entire role. Even the scheduling of the staff is done by the staff. There's a staff manager. She figures out everybody's class schedules and does all that. She does all the budgeting and figures out we're not going to go over our budget for staff wages and things like that. So this is owned completely by students. So let me give you a brief tour, and then we'll summarize. What I really want to do is leave you with a feeling of, oh my goodness, I can use that. I just need some help. If that's your takeaway from this, then I will have achieved my goal. Is that good? Any questions before we dive into that? Okay. Very briefly then, let me give you sort of a setting the stage. The Makerspace is all about solving problems. So let me show you one problem that has been solved by a student in the Makerspace for me, and it has to do with my coffee cup. So I got this kind of coffee flask as a gift. It was a little tea cup from a worker, one of my coworkers in industry. And I really liked it, but I'm also a klutz and I know I'm gonna drop it and break it eventually. It's gonna make me sad. So I asked a student to design a solution to this problem. And this is what he came up with. You can see on the bottom of the mug here, there's what looks like kind of a little funny plastic rubbery kind of thing. I have the other half of it right here just to show you that it's squishy. Okay, so this is 3D printed. The student modeled this. I didn't have anything to do with this other than helping him kind of do a little bit of whiteboarding to figure out how it should look. And he 3D printed this in a material called TPU95A, which is a thermoplastic polyurethane, and that just means it's flexible. It's about as flexible as a watch band or something like that. And so he made two of them, one for the top of my teacup and one for the bottom. And so now when I drop it, it's not gonna break because he designed it. If I hold this up to the camera, it's got little crumple zones in the corners. So this thing is specifically designed to absorb energy. So it makes, I had a problem. I helped them a little bit with the solution, and I've been using this thing for 3 years, something like that, and I've never broken my teacup yet. So that's a small example of the kind of thing that we can do here. And I'm super excited, actually, the physical plant is represented here because this is something we could do for physical plant all the time, and we have actually done some stuff for the physical plant. If you look in the chat, don't be distracted by it right now, but I put in a link to a PowerPoint presentation that contains some examples of things that the Makerspace has supported for a variety of different organizations. There's one from physical plant in there. There's a couple from some other programs where they needed a piece of equipment or they needed something for an in-class example or whatever. And I'll show you some pieces of that in just a second. Okay, so without further ado, let me flip the camera around here and I'll take you on a little tour. Okay, so that's the door, which is pretty straightforward, but I point out the door because most people don't know where the Makerspace is. It's in the Plastics Building, National Elastomer Center, NEC 105. So basically just go into the Plastics Building. It's the one that's right across the little parking circle from the UC. Go in the main doors, hang a left. That's it. That's where we're at. When you come in the door, this is what you'll see. I'll give you a kind of a panning shot here. And then I'll tell you a little bit about what you're looking at. Okay, so let's start over here on this side. First thing, there's a sign that says swipe your ID card. Is that inverted to you guys? It looks inverted to me. No? Okay, cool. So we have the students swipe their ID card. It doesn't take any Bulldog bucks or anything, but basically it lets us query the data later so that we can figure out student utilization, how many students are using it, also what programs they're from, what colleges they represent. And that's great because it lets us go back later to organizations like the Ferris Foundation and say, hey, if we had some more seed money, we could expand this so that more students from College of Health Professions could use this if we added a certain machine or a certain capability or something like that. So that just helps us track. Big shout out to ITSC. This is a computer sort of permanently on loan from ITSC. And the cool thing about this computer is it has an integrated 3D scanner. So students can come in and they can scan things. What kinds of things would they like to scan? Anything about the size of a shoe or smaller. So let's say that you are an art instructor and you want to have a digital sculpture class or a 3D sculpture class. You could have students model something in clay, bring it here, scan it, and then 3D print replicas. So and it's actually really pretty intuitive and easy to use. All the computers in here, by the way, are pretty much donated from ITSC. They give us their best hand-me-downs and we use them until they burst into flames. We've got a couple of small-scale 3D printers over here. These are from a company called Prusa from the Czech Republic. We're starting to use these printers more because they are really, really cheap. We started by buying nice printers, and then we discovered we don't need nice printers, we just need more of them because there were so many students using the space. And so we're testing these ones. They're, believe it or not, the printer that you can buy today for $500 would have cost you $3,000 about 10 years ago or more. We've got a different laser scanner over there in the corner, which appears to be broken right now. I don't know. I'll have to talk to the students about that. Here, you may have seen some news posts about this. We'd spent a good deal of time 3D printing face shields at the beginning of the pandemic, and then later on helped out with Brian Paholka making a injection mold for being able to make those things a little bit more quickly. Got some examples here. This is just 3D printed stuff that's been used in a variety of different applications, but the Makerspace is so much more than 3D printing, as I hope to show you. This one is a drone frame. So that's just the open source little quadcopter frame. And this was used in a class. There was an electrical engineering technology faculty member who wanted her students to do some coding and some programming. And so she bought some components, things like propellers and motors and controllers and cameras and stuff. And the students came down and they 3D printed the frame. And then they were able to fly their drones around, which was kind of cool. Low cost way to do some pretty neat STEM stuff. We've got Bulldogs and variety of this one is actually a failed print, but I wanted to show it to you because it shows how the printers do their thing. They print in layers and the inside is hollow. This one has a support structure inside that's like a series of grids. That basically just means it's really strong. And so we've got all kinds of different Bulldoggy kinds of things. One of the things you're going to hear a lot about today is badging. Badging is a pretty important thing. Well, suppose you want to do more than just digital badging. If you want to do physical badging, there you go. We can make physical badges. If you're talking about things like art, history, travel, culture, we can do manipulatives for classes. So if you want to represent a historic piece of art or a sculpture or something, or if you're a history teacher and you want to teach about the Rosetta Stone, we can print you a Rosetta Stone. If you want to talk about the Battle of Thermopylae, we can make you a little bust of King Leonidas. So it's, you know, there's a lot of different ways that you can use the capabilities of the Makerspace for teaching. Suppose you teach in digital animation and game design and you're teaching about game mechanics. You probably need some miniatures. These, just for scale of reference, I'll put my finger next to this. So little teeny tiny tabletop gaming pieces. I don't know if you guys know this or not, but today is Mars landing day. So I got my little rover out here. It looks like it's missing some wheels. That's okay, I'll just make some more. I love dinosaurs. My kids love dinosaurs, so we 3D print dinosaurs a fair amount. Those are kind of cool if you were a biology teacher talking about paleontology. It'd be kind of nice to pass around skull of a triceratops. Suppose you want to solve a problem, you need something flexible. There's a little example of the TPU material I was talking about earlier. This is a piece of a adaptive welding helmet for a student who has a cochlear implant hearing aid. And basically we had a student make a special welding helmet suspension system that went around his hearing aid so that it wasn't uncomfortable. That's a project actually that still has yet to be finished. This cube basically represents the size of the print volume. Anything that'll fit inside that cube can be printed generally. All right, so those are just some ways that 3D printing has been used. We'll talk about 3D printing and the two types we have, and then I'll move on from 3D printing. These were the first computers, or excuse me, the first printers we bought. They're from a European company called Ultimaker. And these things are a little bit like, if you ever look online and you're looking at buying a used car and you find a car that's like a 2019, but it has 350,000 miles, that's what these are. They're not very old, but they are just beat because we run production level hours. If you average the number of hours they run per semester and divide by the number of weeks in the semester, they pretty much run 8-hour days every day for 16 weeks nonstop. And these printers are not made for that. They're meant for like occasionally printing a keychain. And so that's why they make such terrible noises. I don't know if you can hear it, but this one's like rattling. There's like debris all on the inside of this stuff. We've rebuilt them so many times, they're basically not even the same printer anymore. Like the screens are flickering, the lights are burning out. And it's just because that's how much the students use them. So this one is printing something. I don't even know what that is. Some student designed and modeled something. This is probably for a class. No idea what that is. Got a couple of them over here. Looks like so some availability right now. The students are probably hopping on those pretty quick. Ah, I recognize this one. This is actually one of my students. He's an automotive student and he's making a little desk toy that demonstrates how a turbocharger works. That's kind of interesting. I love my job because I get to geek out with students who love things that I know nothing about. So I learned so much about obscure car parts from a lot of the students. Here's a good example of stuff being broke. I mean, this printer is all kinds of broken right now. I'm not fixing it. The students are fixing it. And I saw actually yesterday, they put in a request into the purchase request spreadsheet for a new repair part for this. So now I think I understand why they wanted that. Got a couple of other printers here. And then this one is my personal fave. This one looks a lot different from the others because it prints in a totally different way. This one prints using a laser to cure a liquid plastic instead of melt a solid plastic. And that's really nice for models with really high detail level, which is pretty cool. What it's sitting on, I'm a little bit more proud of though. This little wooden desk that's perched on top of this cabinet, that was designed and built by a student for this machine. And again, I helped her figure out how the design should go. We did a little whiteboarding session. She did the rest, including getting the material, cutting it out with the Cnc router, And now it's part of the Makerspace. So she's graduated now, and her kind of legacy lives on. When you have no budget for your Makerspace, you make a Makerspace. If you can't buy it, you have to make it. And that's why we've got like donated materials. This is all like elastic, donated from a company in Grand Rapids. Students will use that for prototypes. Okay, so that is, I've got somebody who wants into the meeting here. Let me hit the admit button. Okay, great. So that is the room where all the 3D printers and stuff are. And that's a really, really popular one. This is the one that students use most often. We call this the clean side because most of the machines in here like to be clean. If they're not clean, they tend to have some problems. I'm about to take you into the dirty side. Oh, by the way, big shout out to Physical Plant. When they gave us this room, Physical Plant came over and knocked a hole in the wall and put this door in for us, which was great. Okay, so over on the dirty side, it doesn't look particularly dirty because I told the students to pick up after themselves because of this tour, but normally it's not anywhere near this clean. We've got a variety of hand tools. I'm not going to go into great detail about everything that's here. Little tiny CNC mill, tools for cutting foam board. I'll show you some examples of that in a second. Got some soldering tools. A lot of these are actually donated by students. Like you can see that toolbox has got someone's name written on it. I guess when he graduated, he was like, I don't need this anymore. So he donated it all to the Makerspace. We've got the little support stand there that the Dremel's sitting on, designed and built by a student for the Dremel, right? So students making their Makerspace. We've got leftover things that other programs are getting rid of. We've got scrap material that was donated. We actually act as a recycling center for university printing. Anytime they make a sign out of fiberboard or something, or corrugated board, and they've got a scrap that's bigger than about 2 square feet, they put it in a box and we go and pick it up. So we've got things like cardboard tubes and stuff laying around. We've got some kind of big fume vent hood thing. We're not really sure what we're going to do with that yet, but it was donated, so we're happy for that. Big work tables. The students completely destroyed this thing. Had a beautifully resurfaced top just a few years ago, and I can see it's all scratched up. Whatever, students will fix it. We've got a couple of other things the students have made back here. This is a little tiny CNC router, basically cuts things out of wood, and it's sitting in a frame that was made by students and actually donated by a company. They donated the material for both of these frames right here. This one that has a broken cricket in it right now, that's a vacuum downdraft sanding table so that you can sand stuff without getting sanding particles in your lungs. Got a bunch of scrap materials students have donated. Tool cabinets from University Moving. We've got heavy duty sewing machine. Got some leather working stuff. That's a shoe repair, leather sewing machine. This little box thing over here, this bends wire based on a 2D computer layout. Why would you want something to bend up wire for you? So that you can make Bulldogs, of course. Like that's a whole bunch of little wire pieces that are bent based on a 2D layout and then just welded together, and then we spray bombed it. So yeah, we can make frames and trusses, things like that. Got a plotter donated again. Ferris alumni up in Traverse City gave us that. I think it's still broken, but we've got a very persistent staff member who is gently loving this thing back to life. Dowels are a staple of early prototyping, but when we first started the Makerspace, dowels were getting all over the place. And so we looked around, tried to find a way to store dowels, and I didn't like any of the things that I saw on Pinterest. So me and a couple of students came up with an idea, and a student made this. This actually doesn't exist anywhere else in the world. This is the only thing like this. It's got a couple of different levels for the different sizes of dowels, and it's got 2 compartments per level, one for round and one for square. Those same number of levels are the number of compartments in the tubes on the end. So one of them is for square and one of them is for round. So when you want a dowel, you just find the appropriate shelf, look in the tray, and if there's not a piece there that's big enough for you, then you can grab one out of the tubes. So it keeps everything nice and organized. Those slots are just wide enough that as soon as you cut 1 inch off one of the uncut dowels, the remainder will fit inside that tray. Student designed this whole thing, and you know what? It goes together without any fasteners, fits together like a puzzle, And the thing that holds it all together are the two tubes on the side. They act like keys that hold it all together. It's designed probably about 4.5 years ago, something, by a student. Doesn't exist anywhere else but Ferris. I've got a work table here. This is where, outside of COVID-19 stuff, people would sit around here between classes and they would work on homework and they would help each other with design problems and stuff. That's why we've got it situated right next to our nice whiteboard here. Over in the corner, we've got, again, another little thing that a student designed and built and got donated to the Makerspace. Another little aluminum extruded rolling frame with some CNC router plywood on top of it. It's got, this is gonna be kind of strange, but basically it has a tea maker on top of it, and it boils water, dumps the water down into this little bin here, and then you scoop in some of this material, which is a low melting temperature polyester. And what does that do? Well, it melts it, and then you fish it out with these tongs, and then you shake the water off of it, and what do you make out of it? You make things like what the tongs are held in. You can shape it by hand, and once it returns to ambient temperature, it's this kind of opaque plastic with just really, really high impact toughness. And the cool thing about that is you can remelt it an infinite number of times. So it's really good for making prototypes, doing different kinds of things. And as soon as I found out you could buy that in bulk, I bought 20 pounds of it. And actually the students used it all. So I just bought some more yesterday. We've got bins of Legos down here, again, donated by students. If you've got Legos chilling underneath a bed somewhere, please donate them to the Makerspace. We have students who do prototyping and Legos all the time. It's called Lego typing. And so that's dirty side. Any questions about that before we kind of transition over to some Q&A? I'm going to flip my camera around a little bit too. Let's see here.
Luke, there's a question in the chat. What is the location of the Makerspace?
Oh, great. Thank you for asking that question, Franklin. It is in the National Elastomer Center, NEC, Plastics Building. So if you could just cross the street, across the parking circle next to the UC, there's a building with, looks like a big red barn. That's NEC. Just go in the double doors, hang a left, and that's where the Makerspace is. Can't miss it. All right, so I've got like 7 minutes left, and what I would like to do is just describe some of the ways that you and your team, wherever you end up working, could make use of this. Basically, it takes one of two different modes. You either generate a problem, like, oh man, there's this thing that's broken, or my personal favorite is there's this particular thing that's hard to teach. It's a concept that's hard for students to understand because they can't hold it in their hands or whatever. And you just simply contact me. I just play matchmaker, basically. I just pitch that idea to some students, and then the students work with you to come up with a solution. They make it, and then it's done. The second mode is where we pair classes together. And if you take a look at the link that I sent in the chat earlier, there's an example of this with between product design, where I teach, and graphic design. We'll do a collaborative project where we basically make teams that are interdisciplinary, where I'll send a student to their class to act like an on-retainer designer. And then they sort of make a little mini business inside the class environment. And they develop prototypes together and stuff. And it's neat because it reflects industry, right? Like there's a graphic designer who knows things about how to lay something out so it's visually appealing. They know about fonts and kerning and colors and contrast and all that stuff. My students don't know any of that, but they know about blow molding and extrusion and CNC routing and laser cutting. And so together, they're able to do more than they could separately. That's the way industry works. That's the way academia should work, my personal opinion. And so the Makerspace is the thing that makes that possible. Lori says, saw the sewing machine and the machine that stitches leather, they're one and the same. Actually, no, they're two separate machines. The leather sewing machine is kind of a big green metal thing on some tripod legs. It doesn't work particularly well, but it's the first one we ever bought, and it was like 70 bucks on Amazon. So we'll get a better one if students are interested in doing that. Oh, I should say the leather though. Leather's pretty expensive, except that the original footwear company in Big Rapids, they donate their scraps to us. So students are able to turn pieces of leather, hide that have imperfections on them could never be turned into shoes. The students don't care if it's got a brand mark on it. They think that's cool.
Luke, are the materials expensive, like the plastic? Does that cost a lot to
That is a great question. Thank you for asking that. It is. And actually, that's why almost all academic makerspaces, to the best of my knowledge, they actually charge students for 3D printing, which makes sense, right? I mean, you have to stay in the black. Ferris has chosen to go completely the opposite direction. We offer unlimited free 3D printing for the entire student body. And the reason we're able to do that is twofold. One, there's a very, very high-end filament company, that's the consumables that these machines use, in Grand Rapids. And wouldn't you know it, the company president and founder is a Ferris alumni, graduated from the plastics program. So he gives us stuff at cost, tax-free and all that. And we've helped them out with some design development work and things like that. So that's worked out pretty well, but going forward, we're actually starting to use our plastics facility. I don't know if you guys know this or not, but Ferris has the largest student-operated plastics facility in the nation, and it's just down the hallway from where I am right now. And so we've done actually two successful prototype runs where we've made our own consumables right here. We just bought the raw material and then made it. So we haven't, because of COVID stuff, we were not able to move into full-scale production yet. But I think as soon as everything opens back up, we'll actually have students in a lab make the consumables that we use just down the hallway. And incidentally, the plastics program, to give props to them, they're one of the #1 most utilizing programs for the Makerspace, which is really, really awesome. And they donated the space. This used to be an old vending machine room that they let us camp out in now. It's a great question. Thank you for asking that. So what I hope you take away from this is, man, I'm going to be looking for some problems. The thing that is troubling to me now, the next time I run into it, instead of saying, man, I wish there was a better way. Now I hope you say, man, I wish there was a better way. Wait a second. There was that crazy guy from product design. What was his name again? I'm going to send him an email and see if we can get a collaborative project going. I really hope that happens.
Luke, thanks so much for sharing with us. This was really amazing.
Thank you.
Great to learn. You're doing great stuff there.
Yeah, my role in this is so limited. I don't do anything other than just say, hey, here's a problem. Students, are you interested in solving that problem? And they're like, I got that problem. I'm going to take that problem down. I'm like, okay, you do it.
Awesome stuff, Luke. I put a link in the chat of an article the MEDC wrote about STEAM talent, and we included a plug to the Ferris Makerspace.
Cool. That's great.
I tried the first link, which was, or the second link, the SharePoint link, but it says I don't have access. Was
okay,
that
happened to Dan earlier. Are you signed into Office 365?
Yes.
Okay. That seems to
I
be a
got
problem.
second time. That's what it took. It took me a second time I clicked it. It went
Okay.
in.
Okay. If that continues to be a problem, let me know. And actually, Dan Campbell told me we're with the attendance roster for this session. I'll just email everybody in attendance a copy of that.
I got it the second time too.
Okay.
So.
I got lost somewhere out on the road.
Thank you.
Yeah, very welcome. Looking through the questions here, Lori said, hey, did the students know how to sew already? Nope, they don't, but you know what they've got? YouTube. They figure it out, and nobody's gone to the ER yet. Dee Dee saying about talking about high school students taking Ferris courses, secondary partners, absolutely. In fact, myself and Andrew Peterson were talking about possibly doing this via VR, which would be pretty sweet. Rob says occasionally in HVAC, they've got some obscure repairs. Absolutely. If you got a thing that's busted, let me know, because we could probably reverse engineer and make you one. Maybe even make some design improvements along the way. Okay, great. That ends our session. I'm going to stay on in case anybody has any questions or wants to see anything else. Thank you all so much for coming. If you have any ideas, please let me know.
Thank you very much for the tour. That was very